In this video, we will try to cover two topics: motion in plane with constant acceleration and relative velocity in two dimensions. So let's start with the first one. So let's say a particle is moving in the plane. Let's say this is y-axis and this is x-axis, and this point is origin. So at time t equals to t naught, let's say its position is x naught, y naught in terms of coordinates, and then we can write position vector also here. Let's say this position vector is r naught, and after some time at t equals to, let's say, t, the new position is r and coordinates are x and y. So we can write position vector r naught equals to x naught I cap plus y naught j cap, and final position r equals to x I cap plus y j cap. So this is initial position and this is final position. Let's say at initial time it has velocity v naught, and at time equals to 2 t, it has final velocity v. So we have a term acceleration. What is acceleration here? Acceleration will be final velocity minus initial velocity by time interval. So from here to here, the time taken by the particle is t minus t naught. So we have acceleration, and we can say this is kind of average acceleration. Then if we are setting t naught equals to 0, that is initial time, let's say it starts at 0 reference time, we can say this acceleration is final velocity minus initial velocity by time. So we have one equation here, and the same can be written as v equals to v naught plus a into t. And this, now, as we know, average velocity equals to final velocity plus initial velocity divided by 2. Then displacement will be displacement. Displacement is nothing but final position minus initial position, which we can write final position vector minus initial position vector, and this displacement will be equal to average velocity into time, and then we can write plus v naught by 2 into t, and we have already here v equals to v naught plus a into t. So we can write this displacement equals to v naught plus a into t plus v naught divided by 2 into t, and eventually it will be v naught t plus 1 by 2 a t square. You can simplify this term here, and then we have final position equals to initial position plus initial velocity into time plus 1 by 2 acceleration vector into time square. So we have another equation here, and this equation is for uh, position. So we have come across this kind of equation in one-dimensional motion, where we have written x equals to ut plus half at square, and there x naught was taken to be 0, means the starting position we were taking a reference position as origin. Then this term was vanished, and then we had this thing here. So this one is very simple and common equation we used to see in kinematics. Here the same, a little different notations. Okay, let's say this is equation 1 and this is equation 2. Let us study of motion in plane will become easy if we are studying motion along a straight line. And fortunately, we have technique to transform a motion which is in plane into motion in straight lines along the two axes, namely x-axis and y-axis, and we can analyze those one-dimensional motion, and then we can combine them to get the final result in terms of two-dimensional motion. Let's see how we can do that. So we have here we have one equation. This velocity is final velocity in plane. This velocity is initial velocity. It is a kind of constant because initial velocity will be a fixed quantity, and this is acceleration which we have taken to be constant, and this is time. So how can we uh, resolve these vector quantities to make them as one-dimensional problems? So let's say this is v equals to v naught plus a into t. So along x-axis, we can take final velocity, x component of final velocity equals to x component of initial velocity plus acceleration along x component or x axis, and the same way we can write for y axis also or along y axis. So this way we can write velocity, and the same argument we can carry forward for uh, position, which we will get as this is v naught t plus 1 by 2a t square, and then we have final x equals to initial x plus v naught x t plus 1 by 2 a along x t square, and along y axis we have the same pattern. We can write it this way. So we have resolved the two-dimensional problem into two one-dimensional problems, and this will make easy to solve a problem. We will see its application in more detail when we will study projectile motion. So there we can see how we are going to resolve a two-dimensional problem into its components, making it simpler. Okay, next topic is relative velocity or relative motion in two dimension. So how can we go through it? Let's say there are two bodies moving in a plane. So let's say this is body A with velocity VA, and let's say there is another body VB with velocity B with velocity VB. And then if we want the relative velocity, let's say we want velocity of A with respect to that of B. So this thing we can write as velocity of A with respect to the velocity of B, or relative to velocity of B. And this thing we write simply VA minus VB. This way we can write the velocity, relative velocity in a plane. And of course, here also we can use the same technique. Here also we can resolve these velocity vectors into their components, and we can simply subtract them, and then we can combine them to get the resultant one. So, and there is one more thing. If we write velocity of body B relative to that of body A, this will go to VB minus VA. So, from this thing, these two things, we can say velocity written in this way is equal to velocity of B related to A, this way. So, these two relative velocities have same magnitude, but they are just opposite in direction. What does physically it means? To make the concept simple, let's take an example of relative motion in one dimension. Then we can extend the same argument to two dimensions also. So let's say there is a body A and there is a body B. this is moving towards this way, positive x, and then this direction will be for negative x. So if this body A is moving towards positive x and this body B is moving towards negative x, so let's say this is moving with a velocity of 2 meter per second and this is moving with a velocity of let's say 3 meter per second. 3 meter per second. So velocity of A relative to velocity of B will be VA minus VB. Physically, it means what is an observer will observe if he or she is sitting on body B and observing the motion of body A. This is what written here. So this will be VA minus VB, and VA is 2 meter per second and VB is 3 meter per second, but negative along the negative x direction. So we can write minus 3 and then meter per second. So it will be 5 meter per second. And here we have positive sign. It means the observer sitting at body B will observe the velocity of body A is 5 meter per second along positive x direction. And the same thing we can observe for body B while there is an observer sitting on body A, and this will be VB minus VA, that is minus 3 minus 2, and then meter per second, we will have minus 5 meter per second. That is, an observer who is observing the motion of body B will see that this body B is moving with a velocity of 5 meter per second, but along negative x direction. Here, we need not to be confused about positive and negative sign, because in one dimension, we are using vectors and then we are not using unit vectors and basis vectors. So we can use, instead of basis vectors or unit vectors, we can use simply positive or negative sign. So if we are taking this direction to be positive, then the direction just opposite to it, because we are moving on one dimensional one dimension, so this will be taken to the negative direction, and accordingly we can add this sign with values or numbers, then we can get their vector representation. So we are writing velocity of body A, which is along positive direction. So it will be plus 2 meter per second, which is not written here. And if we are taking velocity of body B, which is along negative direction, so while calculating the uh, actual things, we have to take this term to be minus 3. So the same thing we have done here, and we are getting a very convincing result. The same argument can be carried forward to two dimension also, which we will try to get in next videos.